friends. Let me start with thanking Vaijayanti and Ashok for inviting me here. Um, it's a pleasure to be here and talk a little bit to you. The, I should be talking about mathematics and music. That's supposed to be the session, but well, Ashok probably wants me to talk about mathematics for foundational learning, and I've called it mathematics for living. We already heard Mr. Jaffer asking why the hell do we ever learn trigonometry? Good question, I think. Let me see, which is page down in this? Oh, it comes down like this? Okay. Okay. Fine. Okay, so let me start with an anecdote. This was in the 1990s, and there was this total literacy campaigns going on in the country, and I was very much involved in adult education. In fact, I was coordinating something like more than 100 adult education centers. I was teaching, I was doing things. And my house used to have lots and lots of so-called literacy primers that were there. And there was this Velama who used to come, and one of these itinerant vegetable sellers carrying vegetables on a basket on her head and on her shoulders and bags. And she would come, and we used to buy from her mainly to support her. And she came and asked, "What is this? You're running a bookshop?" And we said, no, you should. And then this is a chance, right? And she was not literate, and so you should attend the adult education class. And one moment, let me just see if I can do it. Yes, I think that's what I should do. One more. Okay, so, and then she, hesitated. How, when do you have the classes in the evening? You have to come every day. And then how long? 3 months, actually it's a lie. And how many books? 3 books. 3 books. Okay, you're a non-literate person to look at it and say, 3 books I have to complete. Then she asked me this question. After completing the 3 books, will I be able to earn 10 rupees more every day? This is what she asked. And question to you is, how would you answer her? I would like to know. What would you say to her? What would you say? I don't know. She asks you this question and you don't know. What? Sorry? You will say yes and say more. Okay, anybody else? This is what you would say? Okay. Anybody else? No is what you would say. Okay. So what would you say to her? I felt like it was a slap in the face. I mean, I have a PhD in mathematics, right? And I have, I got my PhD from Tata Institute of Fundamental Research, which is a frontline thing. I work in math science, and I'm involved in adult education, and she's asking me this question. Now, of course, my attitude was, I have to say yes and make it happen, right? And that led me to a very interesting journey. And I am not here to talk about something that I learned a lot of, things related to math education through that exercise. But here is something I want to point out. Ironically, at the same time, her daughter was going to school, and she was in class 7. Who was spending 10 hours in school? Oh, whatever. How many number of hours in school every day? She never asked this question. She never asked, is my daughter getting this increased earning capacity? Right? Something is going on. So Velama's question is something for us to think a little bit about, is that when she's talking about engaging her own time as a professional, what she's expecting out of it, but then she assumes that education is something that's going to give all this and probably far more than what she thinks, right? So this is now, we talk about various things. I even heard about ROI today, right? How do we look at the expectations of people, right? What are the aspirations of people, expectations? And Ashok gave these numbers, right? That's one staggering thing that we have in India, right? India, Indonesia, China. A couple of years ago, I spent a lot of time in Indonesia working with people doing curricular reform as well. The numbers stagger you, yes. But there are also people out there, people with aspirations, dreams, education is an arena that deals with dreams and aspirations. Let's not forget that, right? And now, what mathematics has to offer, okay, in all this. Now, I would think that somebody who's, coming for any kind of education, if there is anyone who can give a guarantee that you're going to earn more, it's probably mathematics. But is that what mathematics education about? Is that what we are doing? Or to be? I'm not here to promote the economic aims of education. I'm just saying that if we are thinking of mathematics for whatever reason, let's think about mathematics for whatever reason, but let's have our goals clear on this. So an important aim of mathematics education is to turn out employable adults who contribute to social and economic development. In fact, if you read the 1986 policy on education, that's broadly the language that 1986 policy has. And then elementary mathematics will give you numbers and operations on them, measurement of quantities, fractions, percentages, ratios. These are all very important for everyday life, understandings of shapes and area and volume, all this stuff. But of course, mathematics is much more. Much, much more. It has much, much more to offer. In fact, Polya says, if there were any school for thinking, think about it. Supposing you were going to set up a school tomorrow for thinking, right? What would you teach? How would you train your children for thinking? I think, we can get into a good debate. Whatever you teach or not, you will be teaching mathematics. It's for clear that somehow mathematics learning has something to do with learning to think in particular ways, right? Clarity of thought, pursuing assumptions to logical conclusions is central to the mathematical enterprise. Now, there are various ways of thinking, and it's very important to acknowledge that there are various ways of thinking. But there is a particular kind of thinking that one learns in mathematics is an ability to handle abstractions, and that's of great relevance. Somehow we seem to have found across centuries. It means to be able to solve mathematical problems. In fact, not so much about, I repeatedly say mathematics is not so much about the ability to solve problems as opposed to having an attitude to bring to problem solving. A kind of a healthy predisposition where, and this is perhaps the biggest failure in mathematics education that we find today, that when you look, okay, by the way, here is a question. What is 616 by 9? Quickly, somebody, please. How many people can? 616 by 9? This is popularized by the Hindu of yesterday after ESSER report. Please turn to page whatever it is of the Hindu, because it says that very few children in the country are able to find out 616 by 9. How many adults can find 616 by 9? Right? So we should also be very careful about what we are looking for. Right? It's about an attitude to problem solving. See, here, I'm sure people in this room don't give a damn about finding 616 by 9, because they know that if they can't give an answer, they can pull up this thing, find it, and give the answer when it is needed, right? But that's in fact as much part of mathematical thinking to know which resource to employ when, right? Okay, here's another question. How much does a cabbage weigh? Typically, when you go buy cabbage, half a kg, yeah? Yeah, half a kg is a reasonable answer, right? I mean, if you come and say that, oh, look at it and say 531.34 grams, right? You're being ridiculous, right? Who cares whether it's 531 or this thing? Half kg is reasonably good enough. But if you buy gold, somebody says, it's around, 2 or 3 grams here and there. No, of course not. Because there is something that tells us that, of course, if it costs in thousands, third decimal place is important. If it costs in, money that's not particularly relevant to you, you don't care about. So that's much, much more important than the ability to calculate and give. Mathematics is not precision, it's about precision at all. It's about knowing when precision is needed, how it is needed, and how the error matters, right? So that's thinking, right? So it's not about the operations. It's not about doing these things. It's about having a good intuition, right, about things, right? When somebody says 616 by 9, and I don't know how to do it, right? Okay, supposing I was dividing by 10, right? It'll be around 60, right? Okay, I divided by something smaller. It's going to be a little more than 60. This language, this kind of talk is what we are talking about. It's a disposition to problem solving. And what are we doing about that? Now, so also very important that at least at the elementary stage, mathematics provides the only arena for formal problem solving. For most children, until they get to physics in secondary school, the only place where you even look at something like problem solving is mathematics. And this is very important, I think, as a life skill as well. Understanding something's formally posed to you out of nowhere and thinking about it, right? And in fact, I would say mathematics and language education perhaps impart the most critical life skills during the elementary stage. Okay, I don't want to go on with that. Now, what impact does mathematics have on our lives? Of course, the economic dimension, which is what we are talking about, making a living. Right? For most people, it's about livelihood. Now, I have, as I said, I was talking about vegetable sellers. I have worked with vegetable sellers. I have worked with auto rickshaw. People who come to Chennai know what it means to take auto rickshaws, right? And it doesn't matter. You are go to anybody and ask, somebody who's doing any kind of profession, like let's say driving an auto rickshaw. How much do you earn per day? Depends, sir. Depends on what? Well, some days it is this thing. But what about the notion of averaging? Right? When do averages matter? No, this is a person who might have gone to school, might have completed even 12 years of schooling. But the notion of expectation, the notion of chance, the notion of variation hasn't gone in across. Now, for mathematics, for the economic dimension, notions of optimization, notions of probability are extremely important. Right? They're far more important than the ability to get 616 by 9 correct. Right? So, if you're looking for even mathematics from the economic dimension of contributing to socio-economic development or being part of the modern life, what is the kind of mathematics that you're looking for? Then, of course, the democratic dimension, right? How do you understand a newspaper report, right? When today all these numbers are being pulled in about, you mentioned some 6,000 crores or something, right? Doesn't make any sense to me. I'm, a professor earning my salary and so on. How do I even understand these numbers, right? How do I understand these big numbers? How do I understand who's doing what percentages mean? How should I make decisions? How should I understand what decisions are being made on behalf of me, etc.? Then, of course, the aesthetic dimension. Let's not forget that. That's as important for living as anything else, right? We are living in India, right? In India, you can say whatever we can talk about, the disparities, the highs, the lows, but aesthetics hits you all around. Here, there is maths on the street, literally, right? Everywhere you look around, and this is very sophisticated mathematics. Producing an object like that, right? I don't know how many people can draw these, right? This is great fun, right? And in fact, it's wonderful mathematics. Look at a gopuram that you look around, look at architecture. If you're in the north, any kind of Mughal windows, routine one, clothes hanging, and you find one with incredibly beautiful art. It has not come from the people without some mathematics in culture. Right? So I just want to mention mathematics in culture, and I put in patterns and symmetries all around, and this plays a very important role in our lives as well. And these leads to beautiful stuff in algebraic geometry called R modules. So the content areas of school mathematics are very clear, right? For century, unlike in many other things, right? Do you know how old is compulsory science education? When was science education made compulsory in India? Can you tell me? Anybody? Any guess? I don't care. 1950s? Immediately after independence? Just a bit before? Actually, it was much later. 1968, Kothari Commission talked about education policy, talked about science. In Tamil Nadu, for instance, it was 1972, after a Malcolm Asia Committee report, that science education was made compulsory. Right? In Europe, where in 19th century, education for all became big, for the nobles, it was classics and arithmetic. For the commoners, it was science education. That was important. English, of course, whatever, or German or whatever. So, mathematics education has always been considered important from centuries. I mean, it doesn't matter. The Payal schools that existed in Tamil Nadu the Tennai Pallikudams, as we call in Tamil. I'm sure all over India there were forms of education, always taught some arithmetic. So it's one of the oldest things, right? So content areas of mathematics has been clear that what we are talking about as arithmetic is what people have been talking about for centuries. Mensuration, some amount of measurement, some amount of algebra, some amount of geometry, trigonometry, why somebody should answer that, and data analysis. But what seems to be a drastic problem, and that is what I think in the last, after the National Curriculum Framework, 2005, there's been a lot of discussion in the country, is about processes, use of patterns. We saw those beautiful patterns out there, which are around us. Use of patterns, visualization, notions like estimation and approximation, what I just said with the cabbage and the, buying gold. Making connections, use of analogies, formal communication. And that's extremely important. Mathematics teaches you ways of using stylized language in a controlled fashion. Argumentation, and I'm not using the word proof here. Much more important for mathematics is argumentation than proof. And we would like to see children arguing, right? And do we have that? And that's very important for critical thinking. Use of heuristics. This is something that people talk about mathematics as use of formulas. No, not at all. Formulas are intended to work wherever there's everywhere. Heuristics are not intended to work, but mathematicians use heuristics all the time, right? Making conjectures. Not about saying true thing, right? True things are usually uninteresting. Conjectures which could be potentially false, but then you can show to be true are very interesting, right? So if you're not interested in making conjectures, you can't do mathematics. No, this is all mostly missing from school experience. And when I say school experience, I should happily add from undergraduate experience as well. By the time you do get into at graduate level, you look at a little bit of any of these. So I would say then the spirit of mathematics, the joy of mathematics, the reason why those who like mathematics do mathematics at all is mostly in these. If we omit these and bring in only the measurement and getting right answer to computations, you are robbing the whole enterprise of its content. So I would say the biggest problem is the tyranny of the one right answer to be obtained by the one algorithm that has been taught in class. Now, if there is a disease of, in mathematics classrooms, it is this. Can we do that? Liberate mathematics from this. Look at how people do. How do people subtract in shops, right? I go and buy something for 46 rupees and give a 100 rupee note. The person doesn't subtract and tell me 54 and then. Now, of course, if they use a device, they might do that. Otherwise, they'll give 2 rupee coins. And then I said 46, right? And then 150 rupee note. And if I ask that person, how much did you give me? May not be able to answer. But he or she knows that he gave the correct one. That's all that matters. Now, this is an algorithm that's not found in school. How do farmers estimate yield of crops? Now, our country is rich in mangoes. Most places you go, farmers bid for mango when do they bid for it? March and April. When it's just flowering, right? Because it's a lot of money. Of course, if it is Alfonso's, it's a huge amount of money. So you have to estimate correctly. And what are the algorithms that they use for doing that? They are very reliable. That actually means money. And so on. I don't want to go on with this, right? I mean, I'm even including things like how do analysts estimate convergence of series, right? You would be interested in knowing that there is as much art and estimation in this as or geometers construct surfaces. So, okay. It's I see it already there in the handout that you've got, in this Akshara thing, where it also quotes from the NCF. Now, what is your vision of mathematics, right? Mathematics learning. You would like to see it in a situation where children learn to enjoy mathematics. Not learn mathematics, but learn to enjoy mathematics. Because if you learn to enjoy doing something, you will do more of it. If you don't find it enjoyable, you wouldn't. And being children, they should have the right. They should really have, we talk about right to education, right to enjoy education, right to enjoy your lively, for a child, a big part of her waking time is in school. Please understand that, because at home, you sleep, right? On most days, you're going to be spending a big chunk of your time at home sleeping, or sleeping, eating, bath, etc., etc. The rest of the time that you've got for play, it's only a small amount of time. Most of the time is spent in school. So that's the reality. And if that is not enjoyable, it's a huge problem. After that, learning is very hard. And then children learn important mathematics. What do I mean by that? I mean that when you look at a cabbage, knowing that it's going to be around half a kilo is important mathematics. Knowing that when you get into gold, you should talk in third decimal place is important mathematics. Not giving the exact answer to a problem of that kind there, right? Knowing when to apply what is, and children see mathematics as a part of their life experience. Somewhere when you talk about all this stuff, when you talk about something being long, you should be thinking, oh, her nose is long, her nose is short, and is it longer? Is it, twice as long? Can I think less in such terms? Can I have a child thinking in such terms? Children pose and solve meaningful problems. Now, I'm very fond of quoting this thing that I found from UP State Board book, thankfully in the past, which had this problem. And it asked, there are 24 goats and 42 cows in the garden. How many legs were there? Now, unless you are a butcher, I don't understand why you would count legs of goats and cows, right? You could at least make it fun, right? And another one. Mother made 144 puris in a family of 12. How many did each get? Now, when you look at a problem like this, what should be the child's answer? What kind of a monstrous family is this, where mother makes 144 puris? Right? And what kind of a family is it, where 12 people all have equal number of puris? Something bizarre is going on, right? Now, I would like a child to say that. Who cares about the division at that point, right? So that's critical thinking. That's much, much more important for our child than getting a message that all this is, anyway, it's a word problem. Whatever is told in a word problem is going to be nonsense. Anyway, let's just get to the formula. And then you later blame them. Hey, they are only looking for formulas. They are not understanding context, right? So children should pose and solve meaningful problems. And let me be clear, I do not mean so-called everyday real-life examples. Children don't care about everyday. Give fantasy. Something that should be meaningful to children. That's the point. It's something that should be imaginative, something, and the thing that is mostly missing in most math books of any kind is any sense of humor, right? Math, let's get serious, right? So, and children should not laugh at any point in anything related to mathematics. And of course, that's a problem, right? So meaningful, by which I mean meaningful to children. If you're talking about higher secondary, we should be thinking of problems that are meaningful to teenagers, right? The world of the teenager is extremely rich. Now, if you're going to talk about trigonometry that has nothing to do with the world of the teenager, you have a problem. If you're, calculus course has nothing to do with the world of the 20-year-old and 21-year-old, it's a problem. How you teach undergraduate? So, something that's meaningful to you from your lived reality. And then, of course, the central project of mathematics, which is to use abstractions to perceive relationships, to see structure, and that's something mathematicians do very well. Look at anything and look for what kind of structure they can find in that, to reason about things, to argue, once again, the truth or falsity of statements. And I think what is very important, and this is what I'm just quoting from NCERT, right? Whatever we were saying there. The teachers expect to engage every child in class. And this is extremely important. If teachers, I'm not talking about teachers, I don't say teachers engage every child in class. I'm saying teachers expect to engage every child. So if the teacher walks into the classroom not expecting that everybody is going to be part of this, something is wrong with our education system, right? It doesn't matter. Of course, this is true of not just mathematics, but it's somehow accentuated in mathematics, right? You go to any teacher anywhere, teacher is going to say, okay, and it's a reality, right? If there are 50 children, there are 5 children out. And now, let it this be Kovilpatti or Gummadipondi or Cincinnati or Somalia. It doesn't matter. If you have a class of 50 doing math, there are 5 children out there who don't need you, right? They take to mathematics in a big way. You just give them mathematics, they'll take it, right? And this is true in Ethiopia. It doesn't matter wherever. That's true. It is also true, go anywhere across the world, there are, out of those 50, there are 20 sitting there and waiting for the bell to ring and saying what, please put me out of this misery. Now, this is something really a problem, right? Teachers should not accept this as a reality, right? Teachers should want to and expect to engage every child in the activity, or maybe at different levels, right? Everything that we do They call this, I love this term LTHC that Cambridge introduced, low threshold, high ceiling, right? So every activity that we have is a low threshold activity. So then everybody is part of it, and high ceiling, so that, can we change our way of thinking about mathematics in terms of such processes, in terms of low threshold, high ceiling activities, and not in terms of multiplication or division or fractions or whatever, right? So instead of the content dominating, can we think of learning processes dominating our classrooms? I want to end with a quote. This is by Hans Freudenthal, one of the great mathematicians and also a great educator who has written a lot on math education, where he says children should repeat the learning process of mankind as a whole. The pupil himself should reinvent mathematics. During this process, the learner is engaged in an activity where experience is described, organized, and interpreted by mathematical means. It's a handful, but it's a mouthful, but I think it says very beautifully what ought to be going on. This activity is called mathematizing. This activity is mathematizing, he says. And, National Curriculum Framework starts with, at least the discussion on teaching of mathematics starts with, what's the goal of mathematics education? It is to mathematize thought. And repeatedly I keep getting asked, what is this mathematizing thought? So I thought, Freudenthal, I think, gives us a perspective of that. Somehow there is an educational experience, and we should concentrate a lot on the educational experience that children get, right? And if you can organize that educational experience by mathematical means, you would have mathematization happening in the classrooms. And if mathematization happens in classrooms, let's not worry that much about 616 by 9. Right now, our problem is neither is 616 by 9 happening, nor mathematization happening. Thank you.